Hello students, today we are continuing with the chapter Refraction through a lens. But today we are going to discuss a new topic, that is power of lens. When a beam of light passes through a lens, it gets deviated from the path. The deviation produced by the lens is expressed in terms of power. So when you think about power, we think about muscle power. Imagine a man who is standing with a metal rod in his hand, and he is pressing that metal rod, and the metal rod changes its shape and becomes like a V shape. Okay, so we will say, oh, what power. Okay, so the power of the man lies in the fact how much he is able to distort the shape of the metal rod, isn't it? So in the same way, when we talk about power of a lens, the power of a lens is the power of deviating the rays. Okay, the rays which were traveling straight, how much the lens is able to deviate the rays and make them meet at a point. So how closer to the lens the rays meet, that is the measure of the power of the lens. Okay, so a lens which has a smaller focal length, that means which deviates, which makes the ray meet at a closer point, will have more power. So when we consider the power, we have to find the measure of the deviation produced by the lens. So you see here the deviation of the incident ray produced by a lens on refraction through it is a measure of its power. Okay, so what is the measure of the power of a lens? The deviation that it can produce. Okay, so this is about power. Let us consider two lenses. See here, there is a, which lens is this? This is a convex lens. This is also a convex lens, but this lens has a more curved surface. Okay, it is more curved, it is more thick. This lens is more of a thin lens, a flat lens, isn't it? It has less curvature. So you can see this ray makes the all the rays parallel to principal axis meet at this point, but this one meets at this point, so it is little longer than the earlier one, isn't it? First one. So which lens according to you will have more power, first one or second one? Yes, the first one, because it is deviating the ray more quickly to a nearer point, isn't it? So let us see the notes that are written here. Thick lens is a lens having surface of more curvature, is of short focal length and deviates the ray more. A thin lens, that is a lens having surface of less curvature, is of large focal length. So thin lens, large focal length. Thick lens, short focal length. So more power. Thick lens has more power, thin lens has less power. Hence power of lens is expressed in terms of reciprocal of its focal length. Okay, so power of a lens is reciprocal of focal length, because more is the focal length, less is the power. Less is the focal length, more is the power. So power and focal length are related reciprocally. So what is the unit in which power is measured? It is measured in diopters. Okay, so we see here power of a lens. Power of a lens in diopter is equal to 1 by focal length. So reciprocal of focal length in meter. This is very important actually, that whenever you write the focal length in this formula, it should always be in meter. Okay, so that then you will not make any mistake. So remember the formula for power of lens, 1 by focal length in meter. Now depending on the direction in which a lens deviates a light ray, its power is either positive or negative, because we know two types of lenses. One is a convex lens which converges the ray, that is, it makes them meet towards the center, while the concave lens, it moves it away from the center, isn't it? So depending on the direction in which a lens deviates the light ray, its power is either positive or negative. So if a lens deviates a light ray towards its center, the power is positive. And if it deviates a ray away from the center, its power is negative. Okay, so therefore we understand that the power of a convex lens is positive and that of a concave lens is negative. Thus power of a convex lens of focal length 20 centimeter is 5 diopter with a plus sign, while that of a concave lens of same focal length is 5 diopter with a negative sign. So sign also is very important. So if you have two lenses placed in contact, the combination has a power equal to the algebraic sum of the powers of the individual lens. So when a combination of lens is given, you take the power with the correct sign. So if you have a convex lens, take the power as positive 2 diopter. And in a concave lens, take it as negative 2 diopter. So the combination will have a 0 power. Plus and minus will make 0. And hence it will behave like a glass plate. So it will not be a lens at all. Let us try a numerical problem. The power of a lens is plus 2 diopter. Find the focal length and state the kind of lens. So here it is plus diopter. Plus means positive convex lens. So we have already stated the kind of lens. It is a convex lens. Now let us find out the focal length. Power is given 2. So we will say focal length is equal to 1 by power. So 1 by 2. 1 by 2 is 0.5. We will get in meters only. You can then convert it into centimeter and say it is 50 centimeter. So very simple problems are there in your text. Please try to solve all the problems today. The focal length of a concave lens is 25. Find the power of the lens in diopter. So if the focal length is 25 centimeter, you have to convert it into meter first. So 25 centimeter means 0.25 meter. Then power is equal to 1 by f. So 1 by 0.25, that is 4 diopters. And power of a concave lens is negative. So we have to write the power as minus 4 diopter. Okay.